Okay, so we're going to talk about this more. Let's say that we have a graph that looks like this.
Oh, is that to check out which one goes with what?
What's this look like? X cubed, so it's been shifted right, maybe like x minus 2 cubed, and maybe I shifted it down a little bit.
It looks like it's been stretched a little bit.
Yeah, maybe I did that too. You guys get the point, right? So let's say you have that kind of a shape on there. I really don't care about this, but I'm just throwing it up there, okay? And then let's say that you have another shape on there like this. I don't know, I'm not going to make this perfect. That's kind of like an x minus 2 squared, right? I wasn't being real careful about where
do they touch down there at the bottom?
It doesn't really matter.
Well, it does,
but
This is a rough sketch.
it is. And this is like some kind of linear function.
the linear is f to the second.
Right, so how do these relate to each other?
The derivatives?
Think about your derivative rules. If these were like a family of functions and one was the derivative of the other and so forth, which one is the f?
It's
F
the
is
cubed.
the cubed.
So in this case we'd call that f.
The squared f prime and the line f
And
double
why
prime
is
double.
f prime that?
Because you have the cube.
Because when you take a derivative it drops a degree, doesn't it?
Yeah.
Now this isn't perfect, right? But the point is when you go from cubic to squared, you drop a degree. That's a derivative. And this guy would be f double prime. If you take another derivative, what's it
would
going to
be a
look like?
line.
It'd be a constant line, and it would have the slope of this. So where would our other derivative be? Let's try to be a little more precise. We'd look at the slope of this red line.
So it'd be y equals m.
Looks like it's positive, looks like maybe 2. You guys agree with me? For the slope of the red line?
Sure.
So maybe 2 is where our third derivative is. And if we took a fourth derivative, or fifth, or sixth, or seventh, or any more, where are they going to go? 0. They're going to be a horizontal line at 0. Okay? So you can use that kind of reasoning to help you figure out some of those graphical problems. And we're going to have all kinds of other stuff we bring in too. So let me see what one of your problems is. Let's see. They say stuff.
You get to draw them.
Yeah.
111 through 114 are on the drawing.
So let's just draw one. I'll just draw something. My own. So let's say I have
Yeah, I cannot see. That's alright. What's wrong?
now you should be able to do this backwards and forwards. So what do you guys want me to do? Do you want me to call that f or f prime?
It is up to you.
Let's do it both ways.
Of course.
Let's call it f first. And let's draw just a sketch, not perfect. Let's just sketch f prime. So when we sketch f prime from f prime is the what? Slope of f of this tangent line at every point, right? So right here, the tangent line is that line. So you just look at the slope of that line. What is it?
1.
Looks to me like it's between there and here. It goes up 3 over 2, so 1.5. You guys agree? 1.5. So what am I going to do between there and there?
You're going to have a line at 1.5. And then it's going to drop
right
down
here.
to 0.
That way? Cool. So this is f prime. Just to make sure we label our graphs so we know what we're talking about, otherwise it can get messy. You know what? I know how to fix this. Let's call this f prime. We don't have to do any erasing. Call that f prime. The black line is f prime. So then is this green line f prime anymore?
F prime
It's
double.
f double prime. Excellent. Okay. Can we do that? Can you look at f prime and read it the same way?
Yeah.
Yeah, you can. F double prime is Yeah, it's like something to do with f, but it's also the slope of f prime, is it not? Okay, so we got that part. What about once we get here? What's the slope of the tangent line there? It's just 0, so I should drop down maybe like this. I don't think we're technically have any slope. Why are those both open circles?
There is no.
Is it differentiable at -1?
No.
Because of the,
0.
because of the what?
That corner.
That
Oh.
corner. Remember, we're non-differentiable at corners, cusps,
No, yeah.
and stuff.
Cusp.
This is a corner. So it's not differentiable there. It doesn't exist. F double prime does not exist in either one of those spots. Then we go up here.
Oh, so that was a 1.
Now what do you guys think? Corner, should I put a filled in circle or open circle there? If you try to find the tangent line right there,
You still can't.
yeah, I think you can. I think I'm going to fill it in. I think we're all right. That's kind of a smooth transition. So you can still find the tangent line.
So then from
And
there-
then is the tangent line going to be negative or positive? Look at mine. It's going to start out less negative and get more and more and more and more negative until right there when it's going to be back at
0.
So the y values of the second derivative are going to be negative, 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 negative. The most negative, aren't they going to be the most negative
At that.
about right there? What do we call that? In pre-calc we learned a name for that point.
There was a name for that point.
We're going to be doing it a lot. It has to do with concavity, exactly. It's the inflection point. It's where you change from concave down to concave up. Now in calculus we're going to have a way to calculate that, like split. Okay, so I'm going to bring this back up. We agreed the tangent line slope was 0 right there, right?
Yeah.
And then what's happening to the tangent line after that? It's positive, so I'm just going to go something like that. There we go. That's f double prime, right? Do you guys see how I'm drawing this? Any questions? Just think about your tangent lines. You don't have to actually do this, but if it helps, do it. Color coding might be nice with these kinds of problems so you don't get mixed up on which one's which. Use color pencils, use pens, okay? Let's go find f now.
From the same.
Backwards. That might be trickier. We haven't done that, right? So if this is the slope,
It's increasing.
What did he say?
this is the first
F
time we're going
is
to talk about this.
Going positive.
So f is in, if the slope is positive,
And F is increasing.
f is increasing. Do you know about its values, like where to start with? I don't know if we know. We just know it's increasing except for like right here. So I'm going to just draw what f could be like. So I'm going to just start it up here, okay? So I'm going to say increasing, increasing, increasing. It's going up, 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 up. I'm going to do it less. And it's getting steeper and steeper and steeper and steeper until it gets to right there.
And it becomes a line with a
No, then the
slope
slope
of
is
Between
4.
here, it stays at a positive slope just like that one. So I'm going to go like,
Wait, why doesn't it turn into like a?
Because the slope is 4.
Oh,
slope is
okay.
4. That slope is supposed to be
Okay.
4. Exactly. And then it starts, is it going to go down and bend like that? Is f still increasing here? This is trickier. F prime's positive, right? The black is positive.
Yeah.
Do we agree that the black is above the axis?
So it's
So f prime is still increasing. Is it increasing faster or slower though?
Slowly.
So it's going to start to level off maybe. That's an inflection point on f. This is trickier for sure. I don't even know if you guys have anything like this yet. We're going to get there. So it's going to keep leveling off until right here.
Then it's 0.
It's going to have a slope of 0 right there.
Right at the bottom of the hole.
And it would, if this went down, then it would
Go
start
down.
dropping.
But it's going to turn back up.
But I think it's going to turn back up exactly because that thing turned back up. Okay? That's trickier. So just an
Yeah.
example for now. You'll get easier, believe me. We'll have some tricks to make it easy. Right now it's tough. All right, let's see one more example. So when it says like on, let me see, number 103, 104, when it says things like f prime of x is positive, that means the original function is increasing, right? If it says f prime of x is negative, like that, that means the original function is
So like decreasing.
dropping.
As in it'd be underneath the.
It's going down from left to right. This guy is going up from left to right. You don't know exactly how it looks going up, but you can draw
Oh.
a curve going up.
Okay. But what if one like started off going up and then went all the way down completely?
You'd be able to tell that from the derivative. So if it says this for x greater than 2, then you know at 2 it starts going up and keeps going up.
Oh, okay.
Okay?
But if there was no 2, there'd just be the whole thing's going up.
Yeah, yeah. Which would mean it'd have to go like that, maybe a line
Okay.
that has positive slope. Okay, good questions. All right, I thought we'd do 1/nth derivative. We talked about the uses of those in Taylor expansions yesterday. Let's do, I think this is not too bad of one. Some of these can get pretty hard. So, just looking at that, the notation is a little bit awkward, I think. This means what? Does this mean to the power of n?
No, to the nth derivative.
That means power of n, right?
So it's that whole thing to the nth.
This is the nth derivative. How do you think I can find an nth derivative? I think I gotta try a few derivatives and see if I can find a pattern. So let's find the first derivative. Can I do like a prime notation on this?
So could you just do
I guess I could. You could go like this.
X f of x.
Prime. I prefer to go dx personally. That really tells me the derivative more clearly. Okay, so can you guys help me take a derivative of that? We shouldn't have a problem. What's the derivative of that thing?
X times the prime of that
F prime.
times df.
Product rule plus.
1 f of x.
And we've got f of x.
Where
times-
wait, you got the 1 from the x, right?
Yeah.
Yep, product rule, right? 1 times derivative plus other times the other derivative. Okay, let's take another derivative.
d2.
So we'll put d squared dx squared. Okay. Okay, right here, what we gotta do?
F
Sweet.
x. F prime of x.
Is this a product rule?
Yes.
You have one function times another, so yeah. First, what's the derivative of the second one?
F double prime.
F double prime.
Wait. Of the second one.
Second one. First one, second one.
Oh, okay. I see.
Plus
1 times f prime of x.
It'd be 0.
times 1, right?
But why does
First
it go
derivative of second plus second
Oh, I was looking
derivative
at
of first.
the next.
Plus f prime.
Now
of
is that a product
x.
rule? That's just one. You can even erase it,
Yeah,
right?
that's just f prime of x.
That's just f prime.
Where are you giving this other plus?
That okay, that the f of x or x double prime plus f prime is the first product.
When you take the derivative of that, that's the derivative of that. And then another product rule. Okay, let's do one more. I think that'll probably be good. Oh, what can we do with this
Wait,
first?
on the end, Mr. McGee, on the right
You
of
can
the,
pull out an f of x.
but wouldn't it be times 0 because you're
But I don't know
That's
if
not
you want it.
no?
'Cause it's a
Derivative of that is f prime. Done.
Okay.
Okay.
You have
Like
two
terms.
f prime.
Do we see the two like terms? There's two of those.
2f.
Yeah? So if you take a third derivative, let's write it the other way. X, f of x, third derivative. It's kind of the same thing. Watch, we're going to get first derivative of second plus second derivative of first, and then this guy becomes 2f double prime. Look at those like terms again. I think that's going to continue happening if we continue doing this. So x f triple prime plus 3 f double prime. Right? Like terms?
So is the whatever constant on f double prime of x
Let's see if
the
we can write
same
this
as
now.
the prime of the
So
Okay, what's your n in this case? What was n? Austin, you help me. What is n for the first one? Not a trick question.
1,
What is n for the second one?
2,
For the third one?
3.
That matters because you're trying to compare this to the result to develop the pattern, correct?
so
So-
it is x f to the n of x plus n f to the n minus 1, or, you know what I mean?
Do we agree with that? What Caitlin said? No matter what happens, at the nth derivative, whether it's 5, 6, 7, or 8, you're going to have x times 5, 6, 7, or 8th derivative.
Plus
And then plus, that is n.
to the
I have-
f to the derivative of n
That's
minus
1 lower than that. So it's 1 lower derivative.
x.
And that's it. So that wasn't that bad, was it? No.
I don't understand.
Okay, I think we're going to stop there. You guys use it?